Hello friends, welcome back once again, and this is Nagraj SK. In this video, in this session, we'll move to the next experiment, that is from a given vertex in a weighted connected graph, find shortest paths to other vertices using Dijkstra algorithm. So we have to write a C program in such a way that it should find the shortest paths to other vertices using with the help of Dijkstra algorithm, right? So what is Dijkstra algorithm, how it works, right? What is the working principle behind this Dijkstra algorithm, and what are the details related to this Dijkstra algorithm, right? So Dijkstra algorithm, I would like to brief you about what is Dijkstra algorithm, how this Dijkstra algorithm came into picture for programming. So Dijkstra algorithm published in the year 1959 and is named after its discoverer, that is Edgar Dijkstra, who was a Dutch computer scientist. And this algorithm aims to find the shortest path in a directed or undirected graph with non-negative edge weights. Then, before we look into the details of this algorithm, let us have a quick overview about some of the terms like graph, weighted graph, connected graph, and spanning tree, right? So, what is a graph? A graph is a non-linear data structure defined as g equal to v comma e, that is a graph where v is a finite set of vertices and e is a finite set of edges, such that each edge is a linear or arc connecting any two vertices. And what is weighted graph, right? It is a special type of graph in which every edge is assigned a numerical value called a weight. Then, what is connected graph? A path exists between each pair of vertices in this type of graph. That is connected graph. Then, what about spanning tree? What is a spanning tree, right? Spanning tree for a graph, for a given graph G, is a subgraph G including all the vertices of G connected with minimum number of edges. Thus, for a graph G with n vertices, spanning tree G dash will have n vertices and maximum n minus 1 edges. So, these are the four terms we have to understand before learning Dijkstra algorithm, that is graph, weighted graph, connected graph, and spanning tree. So, what may be the problem of this Dijkstra algorithm, right? Here we will be given by a weighted connected graph or weighted graph G. The objective is to find the shortest path from a given source vertex to all other vertices of G. Then the graph will be having some of the characteristics something like this. It will be having set of vertices, that is indicated by an alphabet V, then set of weighted edges, that is E, such that Q comma R, that denotes an edge between vertices, that is Q and R, and cost Q comma R denotes its weight. Then what is Dijkstra algorithm exactly, right? So this is a single source shortest path algorithm and aims to find solution to the given problem statement. This algorithm works for both directed and undirected graphs. It works only for connected graphs, and the graph should not contain negative edge weights. So the algorithm predominantly follows a greedy approach for finding locally optimal solutions, but it also uses dynamic programming approach for building globally optimal solution, since the previous solutions are stored and further added to get final instances from the source vertex. So the main logic of this algorithm is based on the formula that I'll be writing here, that is, so what is the formula, right? So that is distance. So just I'll take d. d of r, that is the vertex, to which vertex we are finding the distance from source vertex to source vertex to the other vertex, that is from r to q. So min of d of r, then comma, then distance, that is d of q, plus cost of, that is, so I'll take just c, cost of q, then r. What is the cost to travel from r to q? This is what the main logic of this algorithm. This is the main formula we are making use of this formula for finding the distance between from source vertex to destination vertex from source to all other vertices. So this formula states that distance vertex r, which is adjacent to vertex q, and will be updated if and only if the value of, that is value of d of q plus c of, that is cost of q comma q and r, cost of q and r, is less than, that is less than d of r. That's what this above formula says, that this formula, the main logic of this Dijkstra algorithm, this formula states that the distance vertex r, which is adjacent to vertex q, will be updated if and only if the value of d of q plus, that is distance of q, vertex q plus cost of q and r is less than distance of r. Then this is nothing but the relaxation. So here distance, that is d, is 1D array which at every step keeps track of the shortest distance from source vertex to all other vertices, and the cost, that is c, is a 2D array representing the cost adjacency matrix for the graph. This formula uses both greedy and dynamic approaches. The greedy approach is used for finding the minimum distance value, whereas the dynamic approach is used for combining the previous solutions, that is d of q is already calculated and is used to calculate the distance of r, that is d of r. So what input it will be taking, right? So Dijkstra algorithm, we have to give some inputs to this algorithm. So what input we have to give? What input is cost adjacency matrix for graph G, and say it is cost, and source vertex, say yes. Then what output we are expecting from performing this Dijkstra algorithm on a particular problem definition, on a particular problem graph, right? So we will be getting the spanning tree, which is having shortest path from s, alphabet s, that is starting vertex, to all other vertices in graph G. So this is how this Dijkstra algorithm works. So let me begin with the code here. So we are writing a C program for this problem definition. From a given vertex in a weighted connected graph, find shortest paths to other vertices using Dijkstra algorithm. So the code is something like this. As usual, the hash include stdio.h. Then after that, I'm going to declare one method here, that is function, that is void, which is a return type of this that is Dijkstra, dig of, just I use dij function int comma int of 20. Then it is a two-dimensional array. Then one more integer array, that is int of 20. Then comma int. And in main method, what we have to do here is, this is so the return type of this main method is void. So here I'm going to consider some of the variables like I comma j, then visited array, that is visited array, it is a two-dimensional array, sorry, single-dimensional array. Then source as a source vertex to indicate which is the source vertex. Then cost as a two-dimensional array, that is 20, upsize 20. Then one more is d for finding the distance between, for storing the distance between two vertices. So these all are my variables I'm going to consider. So first of all, what I have to ask the user to enter the input, right? So for that, I'll be using printf statement here, printf /n, then ask user to enter number of vertices. So what are the number of vertices? So read that value with the help of scanf statement, scanf, then %d address of n, right? So I have not declared that, I will be declaring here n also. Then printf asks the user to enter the cost of adjacency matrix. So printf /n enter the cost adjacency matrix. Then how to read them, right? So we have to use, because it is a two-dimensional array, we have to read all the values of that matrix with the help of for loop. For I equal to 1, then I less than n, then less than or equal to n, then I plus plus. So this is for row value. Then one more for loop, that is j loop, for j equal to 1, then j less than or equal to n, then j plus plus. So scanf, then %d comma and %, that is address of cost array, cost of I and j. This is how we are going to read the adjacency matrix elements or values. Then after that, once we have the adjacency matrix, we need to ask user which is the starting vertex. So we have to enter the source vertex. So for that /n enter the source node or vertex, then read that with the help of scanf, then %d comma and %source. Then after that, once we got the source vertex, we have to apply the Dijkstra function. We have to call Dij, that is Dijkstra function. So what all things it will be taking as a arguments, like source it will be taking, then cost, then visited array, then distance, then number of vertices. And once we are done with this, we need to print the shortest paths, right, from source vertex to all other vertices. So for that, again I'll be making use of for loop for printing the distances between from source vertex to destination vertex. So for I equal to 0, then I less than or equal to n, then I plus plus, then here if there is a condition we have to apply. If I not equal to source, we have to check whether that vertex is I, that is source, or not. So if it is not equal to source, then printf shortest path from particular node, that is %d, particular vertex to particular vertex is %d. Then it will be the source variable will be containing that particular value. Then we are making use of I with vertex, then the distance of I, that particular vertex, that we are going to print here with help of this statement for loop. Then after that, we have to write that Dij function outside the main function. So void Dij, what exactly it is doing here, we are calling that and we are applying here we are calling that particular function Dijkstra, and we are finding this particular distance path from source to all other vertices. So what exactly this Dij function is doing here, right? So Dij, so int source comma int cost of 20, then comma int visited, then int d of 20, that is distance array, then int n, that is number of vertices. So here locally I'm going to consider some of the variables like I, j, then minimum value, then u comma w. Then for I equal to 1, then I less than or equal to n, then I plus plus. So here visited of I instead of I is equal to initially 0. So d of I, that is distance of I in that particular vertex, is equal to cost of source of I, cost of source from source to I, right? This d of I is the distance of that particular vertex. So how we are finding that? With the help of cost array, that is source value from source to I. What is the value? What is the cost? Then after that what we are doing, so we have to set visited. Then initially visited of I was 0. Then after visiting, after finding ith node, ith vertex, we have to set visited array of source is equal to 1. Then distance of that particular distance from source is initially 0. And for j equal to 2 comma j less than or equal to n, then j plus plus. So initially min is we are setting, that is infinity, or else we are indicating it by 999. Then for I equal to 1, then I less than or equal to n, then I plus plus. Then if not visited of that particular vertex, that is I, then what we have to find? We have to find, and one more condition, if d of I, that is distance of I, is less than min, then what we have to do? Then we have to set min equal to distance of I, and u equal to I, that is source vertex. So after this visited set to visited of u equal to 1. Then for w equal to, that is destination vertex, w is equal to other vertices, w is equal to 1, then w less than or equal to n, then w plus plus. So here what we have to do in this, we have to check that if cost is equal to, if cost of u comma v, u comma w, if cost of u comma w not equal to 999, and visited of w is equal to 0, then what we have to do here is we have to check one more condition here. If distance d of w greater than cost of u comma w plus distance of u, distance of u. If it is greater than d of w, that particular vortex, if it is greater than cost of u or uw plus distance of u, then set that dw value. How to set? Here we have to set that d of u, distance of u vortex, sorry, distance of w vortex is equal to cost of u comma w plus d of u, that is distance of u. This is all about the Dijkstra function. So this is how it will be finding the distances from source vortex to all other vortices. So let me check this whether it works properly or not. So click on the run button here and execute it. Click on run button. So there is an error in the line number 28, visited undeclared. So line number 28, so this one, visited. So run it once again. So it is a warning, no need to worry. Then again any error is present here. There are too many arguments to function Dij, so we have to check int cost d. Okay, here we missed a semicolon, so just click run button and check. Still there are errors. So line number 28, go to line number 28. What it is saying? Too many arguments to function Dij, that is Dij source comma cost comma visited comma d comma n. So let me check what all the source is there here. Int cost is there, then visited, then int d, then int n. Everything is fine, but still it is giving error here. So let me remove this. So check it once again. Just a minute. So here one more argument we need to pass, that is int of 20, int of 20. So let me run this once again and check it. Perfect, but still there is an error, line number 48. So I is missing here. For I equal to 1, easily I equal to 1. So click on run button and check it once again. Perfect. Enter number of vortices. We have to enter here how many vortices we need to have in our graph G. So I would like to enter here 5. So enter button, hit on the enter button, enter the cost adjacency matrix. So for that what I will do, 0, then 4, then 8, then 999, that is infinity, then one more 999, that is infinity. That means from source vortex to other vertices. There is no direct edge from source to other vertices, that is fourth and fifth vertex. So this is my first row. Then 4, then 0, then 1, then 3, then 4013, then triple 5, sorry, triple 9. Then the next row is 8, then 1, then 0, then 8 1 0, then 7, then 3. This is my next row. Then we have triple 9, then 3, then 7, then 0, then 8. This is my fourth row, and fifth row is something like this: infinity, infinity, then 3 8 0. So hit the button, enter. So enter the source node. We need to enter the source node. So I would like to enter here source node as 1. So hit the button, enter once again. So it will be showing you people what is the shortest path from source vertex to all other vertices. So what is the shortest path here, right? From source vertex 1 to shortest path from 1 to 0 is 0, shortest path from 1 to 2 is 4, shortest path from 1 to 3 is 5. Then what we have, shortest path from 1 to 4 is 7, then shortest path from 1 to 5 is 8, right? It is perfect. If you want to check it for once again, you can check. You enter the source node with different node numbers, that is from 1 to 5. 1 you may start from 1, you may start 1 to, from 2, from 3, from 4. So based on that, what is the source vertex, it will be displaying you people what is the shortest path from that particular source to all other vertices. And this is how the Dijkstra algorithm works. So if you are having any doubts in this, please do ask your queries, and definitely I'll be helping you people uh, for all your queries. So thanks for watching. And one more thing is, this is the last program in this series, that is design and analysis of algorithms problems. So this is the last problem definition we learned, and if you are having any doubts in all other programs as well as algorithms, please do ask your queries, and definitely I'll be helping out for that. So once again, thank you very much for watching the videos and attending these sessions. So thanks a lot.